Hey everyone, I'm here with Dana Ziegler, Director and Structural Engineer at Providence Engineering. He specializes in both residential and commercial project design. He'll do all the coordination from the initial contract through municipal review. He's done work with steel and wood beam sizing, masonry, concrete foundations, stairs, handrails, trusses, structural steel connections, shop drawings, basically everything and anything you could need from a structural engineer. Dana, thank you so much for coming out and joining us today.
You're quite welcome. Thank you, Eric.
Hey, my pleasure. I'm excited for this. So I'm going to lead with the number one question.
Okay.
People come to me all the time and they say, Eric, I want to remove this wall. Can I do it? Is it load bearing? How do we identify a load bearing wall and remove it?
It's not as easy as sometimes it can be. There's a few things that you can look for. First thing, most houses, when you look at them, when they're constructed, if there is a center wall that divides lengthwise the house, typically that would be your load-bearing wall. It's not saying you can't open that wall up, but you will have to put in some form of a beam or a header, depending on how long that opening you want to have. Everybody wants that nice big open floor plan, so it's a common request. One thing that we always tell people is anything can be done. It's just a question of how much you're willing to spend to get that result. So there's a couple other things that factor into it if you're going to remove that wall. Number one, head height. We always tell people that the longer the span is, you want to open it up, the bigger the beam's going to be. So it may come down lower into the ceiling. So typically we try and make it so that that opening doesn't come down less than 7 feet into a room. Because lower than 7 feet, it starts to become a visual barrier between rooms. Doesn't give you that open feel. But the one thing that's also from a construction standpoint is moving studs, putting in a beam is relatively easy, but we always have to think about what is inside the wall and what is underneath of us. So can we actually sit on something below us? And then also what is in the wall. So if you have a finished basement or hopefully it's not finished, that you can actually verify what is actually inside that wall. Is there ductwork going up in the wall? Is there plumbing going up in the wall? Those are things that can be difficult to move, and sometimes the cost of moving those outweighs the cost of actually putting in the beam. So
yeah, I really appreciate that. That has always been an afterthought for me, because I'll just look at it and I'm like orienting myself and I'm like, that appears to be a non-load bearing wall. It's easy, we'll rip it out. And that's when I realized the return for the HVAC unit runs right through that wall.
Yep.
I'm like, okay, well, I mean, we've got some work, but it's still theoretically possible. I mean, it's one thing if it's just an outlet, because I think if you're talking about a single outlet, that's relatively easy and cost effective to move. But I agree, if your plumbing is stacked through a wall or the HVAC, because that's sometimes it's really hard to tell, because where is it going then to access the second floor? You know, you might not see like a register on that wall or a return directly there, but it doesn't mean that there wasn't a column of something running up and down. And with the basement, what were you talking about before with, were you talking about maybe like reinforcing, putting lolly columns or something underneath?
Yeah. One thing that always happens in a lot of residential construction is sometimes that beam in the basement may not be directly underneath the wall on the first floor. Okay. So what happens is when there's a wall, it distributes that load out evenly among the first floor framing. When you open that up, you create what we call point loads on either end at the supports. And if that point, we got to carry that down into the basement and down to the foundation. If that doesn't sit on top of a basement beam that we can bring the post down and sit it on that beam, then we either have to add additional support, additional beams, maybe there's some columns. If your basement beam is wood, if it's maybe a double or a triple 2x10, as opposed to a steel beam, the wood beams in the basement have a little more limitations as far as the additional load that you can put on them. So you always have to think of what happens on the first floor and then carry that load down to the basement, so that this way you make certain that your load is safely transferred down to the ground.
Yeah. Well, and that's, whenever we're out there, I always say, it looks simple, but I more or less wash my hands of it, because that level of complexity is well beyond me. It reminds me of, I don't watch a lot of HGTV, but I do remember this one time where they're like, oh, and we put like inch thick stone on the second floor master bedroom. And then they got this giant frame. And I was like, my goodness, aren't they worried about falling through the floor? And they actually brought out a structural engineer to verify it, because I think that's what your point is. When you apply additional weight somewhere in the house, it can impact how the rest of the house itself can bear that weight and what happens. And in this case, we're not even talking about adding weight as much as removing supports, which is just as risky. It's like a fancy game of Jenga, right?
Exactly. One of the things that happens when we look at new homes all the time, and in renovations as well, is everybody wants that nice, big, expensive kitchen island. So they put the big, heavy granite countertop on that. And usually the kitchen island is located in the middle of the floor joists. So you put a nice, big, heavy load in the middle of that floor. What happens? The floor joists want to sag over time. So again, you have to think about that as you're remodeling, as you're looking at projects, is what happens to the load. Have I made the load worse or better, and carrying that load all the way down to the ground?
Okay. So let's say I have a house that's overloaded, whether it's because I removed a wall I shouldn't have, or just I had a friend, he installed a brand new kitchen in the house. Here again, he put way too much weight on it, started noticing it was sagging. So that's a great example you brought up. Didn't even cross my mind until you said so. What are my solutions? What should I be doing?
Well, you always have to, every case is different. You have to look at everything. Sometimes it may mean removal of ceilings so that you can access the floor structure. So you can maybe sister up floor joists. If you have a main level in the kitchen where maybe you had some floor joists that were over notched or they were over drilled over time. If the basement is unfinished, then you can usually easily get additional floor joists in underneath of that.
When you say sistering, that's what you mean as well. It's kind of like when you pancakes more wood right next to the joists you have. So you're trying to beef up the wood that's holding the weight.
That's exactly the case. Yes, you sister them up, sandwich them together, glue and nail them together, and then you want to make certain that sistering goes from foundation wall to foundation wall, or from foundation wall to beam. You want to make certain that it's the full length of that span, because otherwise, if you just kind of put it in the middle, it really doesn't do what it's supposed to do. So,
and this is like a fun digression for me. I remember one time we were out at a garage, and they had notched out the joist, just like you said. The joist spanned the whole way across the garage, and there was this one spot, and I'm not sure I can make the shape with my fingers, but it was kind of like notched out like that, so they could put the garage door opener right there, because there wasn't enough clearance otherwise. And they notched out every joist. And could you tell us like how it bears the load? I remember you describing it, you're like, at this point it's a knife, and on the outside it bears it on the interior or the exterior of the beam. And you were talking about the implications of putting holes in joists, and when it's good and okay, and when it's bad.
Yeah, with when you have a member that wants to bend, okay, you put any load on a member and it deflects and it bends to support that load. And what happens is the forces work out so that the top usually goes into compression, the bottom goes into tension. And so normally speaking, when there are holes in the middle of the beam, it's usually not that big a deal. As long as it's not larger than typically a third of the depth of the joist. Drilling single holes is usually not a big deal if it's in the middle. The farther you get closer out from the middle and you start getting closer to the supports, what happens is that stress is no longer trying to bend the beam, it's actually trying to cut through it, because that force goes into what we call bearing. So now all of a sudden that notch takes away the section of the beam, and so it becomes more of a critical issue to fix that notch. It really starts affecting the strength and stability of that beam. And there are guidelines that we go off of. Sometimes it is a case-by-case basis, but there are some general guidelines within the building code that we're able to use and to correct the situation.
Okay, and that's why when you see them notched out like that, it's not uncommon, I'm guessing, for the split to happen at the top of the notch, because you basically turned like a 2x12 beam into a 2x8 or a 2x6 by chopping off the bottom or the top of the notch. So don't do it,
exactly.
people. Don't do it.
And those usually happen when the bathrooms are remodeled over time, and it's a lot easier for a plumber to. I don't want to throw them under the bus, but I will.
It happens. It's not every plumber. It's just a few bad apples.
Yeah, it happens. It's mechanical. It's human nature. And if you don't understand what you're notching and how you're notching affects those joists, it's a very common practice, because otherwise they have to cut the pieces, the wiring, all that has to be done in smaller pieces, feed them through the joists, and that takes more time and labor. That type of thing. So usually we see the over drilling, the over notching. We usually see that in older homes that have been remodeled 2 or 3 times. And it's because you changed the layout. What was a notch that was fine years ago, the plumbing size got larger because the tub got bigger or the shower got added. And so what wasn't a problem before now is a problem.
Well, yeah, and while we're riffing on plumbing, and I know neither of us are plumbers, I've seen the same thing as well where, and truth be told, I can't blame plumbers for it, because there's a lot of factors that go into this. That's just maybe a bad joke. I'm sorry, plumbers. I've also seen it where the plumbers had run the plumbing directly underneath this joist, and now we don't have sufficient grading to allow the sewage or the water to go out of the house. And that's not good either, people. I'm just saying, this is why we make sure we have good experts. Because when I say, if you shop around and you go for the cheapest, cheap you can get, you're just finding somebody who cut a corner in a way that you don't see it, so they can undercut everyone else and get the job. And that's a rule of thumb, but I'm just saying I see it happen all the time, and you're going to kick yourself when you have to go hire somebody to come back in to fix it. Or, Dana shows up and says, your house really here, that's why it's sagging, because you did this all wrong here. So don't do it. Don't do it.
Yep.
I'm going to get off my soapbox.
Yep. It's always easier to ask the question before the hole is drilled and the notch is made than to go back and fix it afterwards.
Correct. So is there anything that we can do? Let's say we have, some height issues like in the garage, and we do want to put in a garage door opener. Have there been any workarounds besides notching? Is this another situation where we can sister a beam?
Yeah, sometimes you can do sistering. There are, we can do engineered fixes where, maybe we have to add plywood on either side of a joist, and that will allow for an oversized hole to be drilled. Sometimes it involves bringing that plumbing below the ceiling, and then you create a soffit in the garage or in the basement. So there are creative solutions. You almost have to look at each condition separately and evaluate. And that's where the good contractor gets creative and looks at, what is the best solution for the project. So.
All right. Well, let's talk about foundations, because this is another hot topic. And I got to be honest, as a realtor, I was scared initially until I started meeting you. You were recommended by a colleague, and I was thrilled when we went out, blown away, and I've been using you ever since. Foundations are scary. They start cracking. Should I run away from the house?
Depends on the type of crack. Depends on the type of foundation. Depends. There's a lot of factors that go into why a foundation cracks. Concrete foundations, which is typical of homes that are built, let's say, from the late 80s moving forward, typically have poured concrete foundation walls as opposed to a concrete block foundation wall. Difference between the two, in case you don't know, for your subscribers, concrete block looks like the inside of Legos, like a stacked Lego block. Poured concrete foundation just looks like a solid mass of concrete. Typically speaking, a poured concrete foundation typically cracks because not necessarily a structural problem, but because as they pour it, water has to evaporate out of the concrete. And so there's a volume of water that has to get out of there. And usually what happens is that concrete cracks because of that volume loss, not necessarily because the wall itself failed. So a lot of times those cracks are what we call temperature and shrinkage cracks. They're not necessarily structural problems. They can be ground out, they can be filled, they can be fixed relatively inexpensively. You want to look for, if it is a poured concrete foundation, does the crack change in width along the height? Usually a concrete foundation will crack vertically, it will not crack horizontally. If you have a horizontal crack in a concrete foundation, that's not good. Usually those are the issues that we get concerned about. A vertical crack, generally speaking, that is going to be something that can be relatively easily fixed. If your home is built from, let's say, early 2000s on, and you have a crack in your foundation, past that time, there are code requirements that say that there's supposed to be horizontal reinforcing run in that foundation wall that ties the two together. And that's why
steel brackets. Is that what you mean?
Not brackets. There's horizontal rows that are run continuously like rings around your basement.
Oh, you mean inside the concrete?
Inside the concrete that actually holds that concrete together, knits it together.
Okay.
Because as that concrete dries, it wants to pull itself apart.
Mm-hmm.
And so that rebar gives that concrete something to hold on to and resist that pull apart force. Mm-hmm. What tends to happen is, even if there is that crack in the concrete, it will not go what we call displacement laterally. You won't see a displacement in the wall. When you run your hand across it, it will be the same plane.
Right.
As long as that crack is in that type of environment, it's not a problem. It's more of a temperature and shrinkage. You have to evaluate every crack and every issue. But generally speaking, I don't get as concerned about cracks in concrete basements as I do block basements. Generally speaking, block basements, cement block basements are very common in the southeastern Pennsylvania area because of the availability and the efficiency of concrete block versus concrete for years. You get outside of the southeastern Pennsylvania area, you don't see as many concrete block foundations.
Okay.
Don't see them as much anymore being built new because concrete is much more inexpensive and cost competitive with the masonry. Masonry basements typically are not what we call reinforced. So it is basically just the stack blocks, and it depends upon the bond of the block and the mortar working together to resist the soil forces. The biggest thing that affects a concrete block foundation is water and the water pressure against it. So most times a concrete block foundation is probably going to crack because check your gutters. Are your gutters working properly? Are they getting the water away from the house? Typically, if there's a property where maybe it sits on the market a long time and they're not maintaining the gutters and there's water that's laying around the outside of the foundation, it creates a lot of pressure of water against that outside wall. And if you think about a swimming pool, that pressure increases as you go down. And what happens is that water just wants to push that wall, bend it. Block is not real strong, and when it bends, it's very great strength if it's pushing down compressive loads. Very strong. You start bending it, it doesn't do very well, cracks. So there's a few things we can do. Every situation is different. You have to evaluate every horizontally cracked basement. Like I said, typically that's going to crack horizontally, but there are options. Don't run away from it. You can do things as far as maybe core filling the basement wall, filling it with concrete, depending on whether you have a finished basement, not finished basement, height of the wall, those type of thing. There are carbon fiber reinforcing that's possible. So it's not run away from it, not run for the hills, not forget about it. It's not a big deal. You have to evaluate each one. And as long as, like I said, the main thing is on the outside perimeter, can we get the water draining away from the basement? Is it a good dry condition? You know, is your sump pump working properly? Those type of things.
Yeah, so I like to describe it as like a stick when I'm out with people and the reason I pick a stick is because like when you're talking about the vertical column, when you start pushing on it, where does it crack? And number one, it always cracks in the middle, which that's
Hmm.
where I always see the cracks. I mean, maybe
Yep.
it shows up somewhere else. But then I also do analogies about like tooth decay. And I was like, look, I mean, like if you've got a cavity, you can fill it and fix it, or you can wait for it to get worse and get a root canal. So,
Yep.
and I was shocked how affordable it is. And
Hmm.
it's not to say that it's nothing, but
Yeah.
I have done plenty of basements where, you know, we went out and shopped out with contractors and we're talking like $3,000 to
Hmm.
take a cracked foundation, reinforce it where you came back and you did the analysis and you said, yeah, if you filled the cores and you said like 1 out of 2 or every one or whatever the number
Yep.
was, sometimes we had to reinforce with rebar, sometimes we didn't. It's a lot of manual labor, but the concrete that goes to fill the block, relatively affordable. And then you're just getting the gutters away. Now,
Yes.
I don't know if this is correct or not, but I've been told before that if your basement goes underground 9 feet, then you want to make sure your gutters go like 9 feet away from it. Is that an accurate statement, or do you have any insight on that?
The main thing, uh, yes and no. Code would require, from a building standpoint, the building code says that your gutters need to extend. The downspout should extend a minimum of 4 foot away from the house. I always tell people that look at your flower beds that are around your house.
Mm-hmm.
You want that gutter and downspout to go out at least as far as your flower beds.
Mm.
Try and get it out that far. And I definitely would say the farther away from the foundation, the better. But what's more important, it's not even so much the gutter, it's the grade. How does the grade around the property, does that really drain that water away? I would say, we've got a lot of rain right now going on the last few days.
Yep.
So today is a great day to go around. After a rainstorm, if you have standing water right around, let's say within 3 to 4 feet of the outside perimeter of your house, if you're seeing that water standing there after 24 hours, you really should be doing something with that grade, because what that is doing is putting added pressure on your foundation. If your sump pump is running constantly after a rainstorm, it could be just simply the water table has raised up to the point where it's at the bottom of that sump pump and creating kind of an endless cycle. But if you constantly are having that thing running and the sump pump is dumping right at the outside of your house, again, same thing, get that sump pump discharge, get it at least 4 to 5 feet away from the house, draining away from the house. Those are the things that I would recommend to people.
Yeah, that's an excellent point. I mean, yeah, the gutters came to my mind, but yes, you're right. And the grading that you're talking about. So if this is my exterior wall and this is outside, the grading also needs to be going down underneath the flower beds that you're referencing, because
Yeah.
people dump a whole lot of mulch on it, not realizing the grade under the flower bed leans towards the house. You're
Yes.
fundamentally just funneling water back towards your house.
Yes, exactly.
Which
Yeah.
isn't good either. And
No.
so with the Penn State hat, I read like an article out of Penn State where they were talking about how when water goes in, number one, most of the water just runs off the surface, which is why it pools so much. And it goes in kind of like an ice cream cone, which is why you're saying push it away from the house. Because if you dump a gallon of water right next to your house, well, half that water is basically going to sit on that house and just going to try and expand as it goes down.
Yes.
So,
yeah.
Which is where we get the efflorescence, right? I think you told me,
Yes.
is it 1 pound per square inch? It's not very much water to get that.
It doesn't take much, no. And usually what happens, it tends to happen on block foundations more than it does on concrete ones. And what that is it's kind of that scaly, powdery feel to the block wall. It kind of flakes off. And what that is that's the minerals and the water coming through the block, moisture working its way through the block and creating a problem on the inside. And usually there's not really a great way to cure that, short of digging on the outside of the perimeter and waterproofing and sealing off the moisture from the outside. That solves it. The other way you're doing it is really mitigating the issue. Then you get into painting dry lock or some kind of sealer on the inside surface of that masonry to stop that moisture from coming through the inside. But then you have to deal with the moisture in other ways. So, agreed. The better is to keep the water away from the house if at all possible.
Correct. For me, it's less about the cosmetics. I mean, the cosmetic is an issue, but I never understood dry lock because I looked at it and I said, okay, well, great. You know what that does? That prevents me from seeing the efflorescence, which the efflorescence is a problem to begin with. And all it really does then is stop the moisture from coming into the house and accumulating in my basement. But at the same token, I feel like you're basically covering up what is otherwise a problem. Because even if it's only ever efflorescence, to me, it's an indicator of you might have a problem going forward. You need to get that water away from your house.
Yes, exactly.
And aside from a little bit of staining, it's not the end of the world. Just get rid of it. That's like when you go,
exactly.
I'm sorry, all about analogies. When you go to the dentist and they say, you got a lot of plaque. They're not saying you need a root canal. They're saying brush your teeth, floss more, please. Take care of your dental hygiene and your house. Sorry.
No problem.
I'm enjoying this too much. All right. So I wanted to talk about also the cracks. Now you talked about like the vertical ones, whether they're settlement or the moisture in there. I've seen people fill them. Sometimes they're scraping stuff on top. Sometimes they're squirting stuff on top. What are the different options and which one is typically the better option for us?
Yeah. Again, kind of depends on whether you're talking block versus concrete. Okay. A concrete crack, if you think about it, if concrete cracks and you're seeing it on the inside, go around to the outside. If will depend on where the grade is on it. If you're seeing that crack on the outside at relatively the same location, it extends all the way through that foundation wall. So if you think about it, if you only scrape the surface on the inside of the basement and you fill that, you still have 90% of that crack is not filled. It still hasn't corrected itself. So what we always recommend is grinding that crack out in concrete and then injecting through pressure. And there are various different kits that are sold, whether they're through the local distributors or whether you bring in a contractor to do the work. There's different levels. But you inject it under pressure to fill that crack. You want to fill that crack completely. And the only way you're going to do that is to think about it is to kind of get a little bit more of an opening, grind that out, and then fill that crack with some kind of an epoxy and go from there. That's what we suggest. Now, in masonry, it's a little different in that.
In masonry is the Lego blocks that we were talking about before.
Correct, yes.
The things that look like giant bricks, but they're typically gray.
Yes, exactly.
Familiar with that nomenclature.
Yep. So when you have cracks in there, if you think about it, when block is joined together, there are two lines of mortar that are set, and then the block is then set on top of that. So if you think about when that crack occurs, in order for one to crack, it almost has to crack the other side. So you have a crack on the basement side and then a crack on the outside side of your basement.
Right.
Most people will only fix the inside one.
Right. I'm not going to dig up the outside,
Yeah, exactly.
Dig up 4 feet and go down and build a hole big enough for me to go down there? No.
Yeah. They'll only do
I mean, I probably should, but who does?
Yeah. So, and that's where what we always recommend is to, when you have a horizontal crack that has opened up a little bit, you see a little bit of movement in that wall, that's where we always get into. We think it's better to core fill certain locations along the length of that wall to essentially maintain that vertical tie. Because otherwise, if you're only fixing the one face, you still have a crack on the outer face of the wall.
Yep.
So that's why we like to see more of a, and I don't want to call it an invasive fix, but more of fixing both faces if possible,
right,
and restoring the integrity of it.
Yeah, it's a more substantial fix because that's what's going to ultimately link it. I had a client, he was from South Africa, and he told me, whenever they did block in South Africa, what they would do is they'd put the mortar down, they'd drop the block on top, and then they'd fill the core of the mortar, or fill the core of the block with mortar up halfway. And then when they put the new block on top, they'd fill it up to halfway of the next block, because what they're basically doing is linking each individual one. Now, I don't think their block were I assume their block weren't quite as structurally sound as ours, since they had to fill the core on literally every house that they ever did. But I found it to be an interesting approach versus, like you're saying, nowadays, if we had a crack in a masonry or a block foundation, we'd probably just go straight to the top of the column, try to fill the entire length because it'll strengthen everything. And that way, you know, it went all the way through. And do we need to bore that hole in the bottom to see the concrete coming through, or are you just trusting it when we, you know, shove a stick down it?
I feel it's always better to have that hole at the bottom. That way you can see that concrete coming out. You can verify it, that type of thing.
Yeah, because last thing you want is it get stuck like halfway up, and now you think you fixed it, and you don't notice you didn't put enough concrete in.
Correct.
Or whoever you hired didn't put enough concrete in for all
yes.
that.
Yeah.
Good. All right. So can you comment about sagging roofs? I see this every now and then where the roof is really wobbly. And I know you're not a roofer, but you know, could that be a structural issue, or is that just a roof install issue?
Well, a roof can sag for a number of reasons. Okay. And again, kind of case by case basis. When we look at roofs and we size them, we size the rafters. Rafters are what actually holds the plywood or the sheathing surface. That's what's carrying your load. And then you have ceiling joists that form the second floor or the ceiling of your upper level there. And the way roofs work efficiently is a triangle. Rafters form the peak, and then the ceiling joists form the bottom, and there's connections at the base of the wall, at the top of the wall of the second floor or first floor if it's a rancher, of the rafters and the ceiling joists together. And think about a triangle. You push down on a triangle, it doesn't want to move, okay? And now that's not saying that the rafters themselves aren't bending. So you have to have rafters that are strong enough to resist that bending, and there also has to be a connection at the base. Now, with the advent of the big open floor plan and a lot of vaulted ceilings, that kind of thing, we can get into load-bearing ridges and all that, but let's just right now stay with the traditional roofs that we see with flat ceilings. So if rafters are not sized properly, in our area we have a 30 pound per square foot snow load, which is in our area 30 pounds a square foot that we designed for equates to about 15 to 16 inches of snow.
Okay.
So, and we look at that snow hanging around for 7 days. So now this past winter, we did not have that. We had a very warm winter, but we have had snowstorms. Think about where it's been March and we get 24, 26 inches of snow dumping on a roof, and it may hang around for a week. If you actually took a shovel, cut a section out and weighed that snow, it would be probably at least 25 to 30 pounds per square foot while sitting on your roof. So that's how, when we look at designing a roof, we look at that load. Code does allow you to reduce that a little bit because they say the percentage of that occurring, it's enough to outweigh some of the risks. We look at it and say, we know what happens, so let's just design the roof to take that 30-pound snow load. So we don't reduce it. But anyway, when you look at that roof and it, their member sizes 2x6, 2x8, 2x10. Again, it depends on when your house was built. My grandfather was a builder, and he always went by the rule of thumb: 2x10s for floor joists, 2x8s for ceiling joists, and 2x6 for rafters. It didn't matter how long the span was. Consequently, you go around to a lot of homes that are built, let's say, from the 50s and 60s, and you put a string line from the bottom of the roof to the top of the roof, you could see a pretty good sag to it. Mm-hmm. The one thing that we look at when we look at these roofs is there's a difference between bending and sag. They're separate things. They're two separate properties of a roof. Just because a roof is sagging doesn't mean that it's not strong enough to support that load. It just doesn't look nice.
Okay.
So by today's code, we kind of try and balance the two. We want to make certain that the roof definitely is strong enough to support that load, but we also don't want it to deflect that much. So one thing that we look at in newer homes is, existing homes, is we obviously don't want to have a roof that will not support 30 pounds a square foot, but it is possible that roof does support the load, but it just sags. So we try and comment on that to people.
So what's sagging represent then? Because sagging is
sagging,
like over time it starts to dip, right?
It does. One thing that is wood is a very unusual material. It has memory. A piece of steel, you put a load on it, you remove that load, it springs back to a zero position. Wood, if you put a certain load on it and you keep it there long enough, it deflects, but you take that load off, it doesn't want to come back up.
Right. Like a rubber band, you stretch it too much.
Right.
It always stays stretchy.
Exactly. So that's where the code sets certain limits as to how much we're allowed to let that wood deflect to support the loads. So one of the things that I will bring up to people, if you ask us when we're looking at an existing home, what conditions the roof is, we may make a comment that says your roof is strong enough, it will support 30 pounds a square foot, but you are going to notice when you get 30 pounds of snow on there that roof is going to have probably a little more sag that you and I would feel comfortable with. That's not necessarily means it's going to come down. It just means that it's got a little bit of a sag to it. So we just have to look at each individual case. And there are charts within the code that we go by that set that limit that we're allowed to look at.
Yeah, and that's something that I've built a larger tolerance for the longer I've been in real estate, because that reminds me of like old farmhouses. You go in an old farmhouse and you feel like you're walking cockeyed. You might be, but are you walking cockeyed because it's a 200-year-old home? Or are you walking cockeyed because there's something wrong with the home? Yes. And sometimes it's frankly very tough to tell the difference, especially as a non-expert. But there have been other times when I looked at it and I was like, oh yeah, I mean, I'm pretty sure this is just a byproduct of they had a ton of junk here. Like, oh, this was where the bed sat, because you can see that 4 posts. They must have had a heavy bed or something like that, because it only sags in those spots. And structurally, all the doors and the frames and the windows seem okay. So I'm assuming that it might be okay in that situation. Can you weigh in on that? Yeah. Is that the same line of thought?
It's kind of the same line of thought. It also applies if you think about in like a shopping mall condition. If you are standing on the balcony in the corridor, standing still, and there are people walking past, if you close your eyes, a lot of times you actually can feel people walking past you. It's because your mind picks up the vibrations of somebody walking past.
Yep.
That balcony was designed for a load much heavier than what it is experiencing at that time. It's just your mind picks up those vibrations. And now what we do is when we're looking at brand new construction and we're looking at floors, we actually assign ratings to that floor to minimize that deflection and that floor vibration. So one thing to think about is what we call a hard surface, hardwood, tile, those type of surfaces transmit and you feel floor vibrations a lot more than carpet.
Okay. Yeah.
Also, a home that has what really helps floor vibrations is weight, what we call dead load, the self weight of the structure. So if you have a room that is completely open, there's no furniture in it, and one person walks across the room and one person is standing in the middle of the floor, they're going to feel that. You take that same room and you put a bunch of furniture in it, put a couple chairs in there, and the same condition, and how those people feel that floor is going to be different, because there's weight on the floor to kind of deaden and what we call deaden that floor and that vibration out. So it's
and I'm sorry, I'm just going to geek out for a second. Is that a byproduct of the fact that you have more mass that is acting as like a shock absorber, or are you saying that's because the joists and the flooring itself is bearing more weight, and because there's more force, the limited force that's being transferred through it has a smaller impact. Like Newton's law, a body in motion stays in motion, a body not in motion. Because you've got to counteract that force then, right? But then arguably the energy's, see, this is where I'm geeking out. I'm sorry.
Yeah, no, it's okay. No, what happens is you have think about something that already has a certain amount of load applied to it. So it already is deflecting a certain amount. Then think about, acts more like springs, and it is kind of like shock absorbers. If you start applying something that has absolutely no load and it's at a 0 point, and you apply loads to it, it's going to deflect from 0 to something. Mm-hmm. And it's just a matter of how that load spreads itself out, how it deadens itself. Certain things, as far as if there's a wall that runs perpendicular to the joist span, that will spread that load out as well. So it's an unusual phenomenon. And I always tell people that just because a floor feels bouncy, just because a floor sags, doesn't mean that it's not structurally sound. Mm-hmm. So you have to kind of look at all the characteristics. But I will agree with you that farmhouses have a lot more sag and a lot more movement to them than anything. And also the one thing, as builders, and they are right, we're using different lumber than was used 100 years ago. Now it's more of an engineered, controlled growth. It's new growth. We're not harvesting the old growth. So as a result, they are right to a certain extent. The wood on the open market today is not the same as it was years ago. So consequently, if you look at some of the design values that we use, we're using lower design values because the wood may not be as dense. It may not have some of the strength values that we see in some of the older wood.
Yeah, I mean, anyone who's been working with the material for a long time will attest to that, whether it's the number of knots that you've seen, or like you're saying, density, which had no idea that was an issue. The other one people always talk about is a 2x4 is no longer 2x4, just a hair bit smaller.
Yes. Agreed.
Okay, we have Dana watching out for us. It still does its job. Don't worry about it. Mm-hmm. Or maybe worry about it, but then learn the science, and he'll explain it. So if there's anything else you want to highlight, feel free to jump back into it. Oh, you know what? There's one other thing I want to bring up before we transition to another line of thought. Exterior walls. So let's say I have a masonry, concrete, stone, whatever, stucco wall. I want to put a door in, or I want to open it up for a breezeway or something. Can I do that? Can I open up an exterior wall?
You certainly can. You have to look at different conditions. Some walls may be bearing, some walls may not be bearing. You have to look at what kind of wall you have. Sometimes what you see on the outside is what we call a veneer wall. A lot of times brick homes, or brick on the outside of a home that may be 30, 40 years old, that's not what we call a built-up brick wall. It's a veneer on the outside of maybe a frame wall or that type of thing. So those are approached in different fashions. Certainly can open up walls and create openings. You're going to have a header or a lintel that has to be installed. There's a number of considerations. What's the appearance going to be? Are you going to now close that exterior surface up? Or are you going to expose it? So it's always best to bring in a qualified contractor to evaluate the conditions. Call us in to look at what kind of loading is on that wall. If it's a non-bearing wall, usually not a big deal. If you're opening a window or a door opening in an 18-inch stone wall for an old farmhouse, that's a totally different aspect than opening up a wall in a home that has vinyl siding and 2x6 framing. So
but to your point earlier, it can still be done.
Oh, absolutely. Yeah.
It just depends on the price and what all is there. Because I think if we're talking about farmhouses, isn't it something crazy like 100+ pounds per square inch on each one of those, on those fieldstone foundation walls?
Well, a cubic foot of stone, 1 foot by 1 foot by 1 foot,
Right.
will weigh on average between, depending on the type of stone, anywhere from 125 to 150 pounds per cubic foot.
Ooh.
So you start thinking, stacking that up on top of each other and all that. There's a fair amount of weight that comes down on those openings. So that's where it's always good to, before you start knocking holes in the outside of a building, to make the phone calls and make certain that you're getting the right person looking at the structure, looking at the opening, making certain that it's properly supported, and not just in its final form, but supporting the existing framing and the existing house as you're doing it, because that's always just as important as what the final product is. You want to make certain everybody's safe while the work's being done.
That's a great point. We hadn't even talked about that. Like when we were saying, open up a walls, you guys, whoever does it ends up framing it and burying that load right there while they're removing a wall, if it's load bearing, and they rearrange stuff. So, you don't want to knock your house down by accident when you're trying to open it up.
Yes.
That would be bad. All right, let's transition. I know you work with a lot of other individuals, not just people who are opening walls in their house or dealing with foundation issues. Where do you want to begin? Do you want to talk about like some of your work in new construction? If somebody wants to build, a beautiful home or put on an addition to their house?
Yeah, we work with a number of different people. We always tell people first off that we're not architects, we're structural engineers. So when it comes to, we've done everything from reviewing, let's say a builder comes to us with a set of plans and he says, this is what we want to build. The township wants us to be certain that this is structurally sound, meets all the design loads. We need someone to review the plan, make certain that it works. We certainly do that. We work with contractors, we've worked with realtors, directly with homeowners, reviewing those plans to make certain that all the plans meet the applicable structural codes and building codes from a design standpoint. We don't like to get involved with a lot of design per se, architectural design, because that's not really what we do. So we like to work with number of different people. We work in all different markets, of the building industry, everything from commercial to residential to industrial. We've pretty much done it all. Warehouse facilities, whatever building oriented we get involved with.
Yeah, I mean, I brought you out to a couple where, we either had a restaurant we were trying to open up, or, we had garage space that we were trying to retrofit. I'm trying to remember what the one crazy one was. The guy was like a meat packer or something like that. And we were worried about the building caving in because I think it was actually, as I'm like trying to remember the situation, I think we thought it was going to fall down or something like that because there was a giant bed of dirt off the back, and it looked like that the building was starting to drift away from
fall in.
Yeah, and I was like, that's a problem. Maybe that's why it's such a good price.
Exactly.
But I also appreciate you taking the time just to say, like, look, if you want somebody to make it look pretty, go find somebody to make it look pretty. Architects. If you want somebody to make it structurally sound, that's where you come in. And anyone who's done new construction, whether it's you're doing a lot of things like a community or you're doing a custom home, it's always that balance, because what the architect might think is, aesthetically appealing might not be the most intuitive way to build it, which I think is a whole nother line of architecture where they say, like, can you make something that's counterintuitive and has like giant beams shooting out? Yes, we can. We just might need a lot of steel or reinforced concrete or something.
We try and make
I don't know.
We make the dream a reality is what we try and do.
Yeah, exactly. Is there anything you want to highlight, like important considerations? Let's talk about maybe like pole barns, or when people are trying to put on like a separate. I have a lot of people do like a 5,000 square foot metal building to run their contracting business out. Is this something that people frequently contact you with? Are you sending people out to buy kits? What should we be doing?
There's a number of different avenues that can be done with that. Normally speaking, when it's a pole building, a lot of times they will do a lot of that design. The contractor will do the design themselves, and they will bring that design to us to review to make certain that it meets the applicable codes and the structural loads. So we do that a fair amount. If it's a metal building, again, sometimes that design can be done by the fabricator themselves. They'll have that design capability in-house, because they'll actually design the beams completely rather than using some stock sizes. But we've done everything from designing from ground up, doing just the foundations for the pole buildings, or just the foundation for the pre-engineered metal building. And we've also been the reviewer for the entire structure. So again, we're willing and able to talk to anybody for the size projects that they have in mind. We may not always be the perfect fit, but we always like to recommend the people that can get the project completed for the client.
And that's all we can do. You know, there's a tool for every scenario, and I view it as the same thing. I've had people talk to me about, you know, am I the right realtor for a specific job? I said, well, bring the job to me and we'll figure it out together, because frankly, you know, I may not be, depending on what you're looking for. You know, you want somebody, and I'm just going to riff on my own. If you want somebody just to throw it up on the MLS and you say, here are the pictures, just put it in and call it quits, I'm not your guy. You know, that's where people go down the wrong path, and you're going to end up disappointing yourself by thinking, oh, I'm going to save a buck or two here. No, if you want it done right, let's go do it right. So that makes perfect sense for me. And I forget where I was going to transition after that, but yeah, reach out to Dana. That's why I call him the number one structural engineer that I call all the time.
No problem. Glad to talk to you, Eric.
Likewise. And thank you so much. If you guys have any follow-up questions for him, I'm sure he'd be happy to talk to you. Just give him a call or shoot him an email or drop a message below, and we'll make sure to connect you guys. Thank you very much, Dana.
Thank you, Eric.
I'll talk to you soon.
Very good. Thanks.